is Fiona and my group members are Abdurrahman, Amran and Harshan. So today we are going to present about experiment 7, which is the estimation of heat capacity and entropy generation. So I will start first. For the abstract, this experiment was carried out to estimate the heat capacity of different metals provided and to estimate the entropy generated when these metals are dropped in a container containing water. Three different metals have been provided in this experiment, which is iron, aluminium, and copper. Metal is weighed on the weighing scale and the value is recorded. Then 100 ml of water is filled into the first beaker and it is heated. Metal is lowered inside the heated water until it is fully submerged. 100 ml of water is then filled into the second beaker and the initial temperature is recorded. When the temperature of the heated water reaches 80 degrees Celsius, the metal is then moved into the second beaker. The top of the beaker is covered using aluminium foil and the temperature of water is recorded for every 10 minutes intervals until constant temperature is reached. By the end of the result, the heat capacity and total entropy is calculated. The value of heat capacity for iron is 0.8120 kJ per kg.K. Aluminium is 1.7622 kJ per kg.K and copper is 0.6756 kJ per kg.K. While for the value of total entropy generated is equal to 0.0009 kJ per K for iron, 0.0007 kJ per K for aluminium, and 0.0008 kJ per K for copper. A bar chart of heat capacity is then plotted. From the graph, aluminium has the highest heat capacity compared to iron and aluminium. Next, we will move to the objectives. So the objective of this experiment is first to estimate the heat capacity of different metals provided, and second, to estimate the entropy generated when these metals are dropped in a container containing water. And then we go to the introduction. Different substances absorb heat at different rates due to various structural factors. The heat capacity of a substance is the amount of energy required to raise 1 gram of a sample by 1 degree Celsius. In general, when a body at higher temperature is brought in contact with another body at a lower temperature, the heat lost by the hot body is equal to the heat gained by the cold body and some intermediate equilibrium temperature is finally reached, provided no heat loss to the surrounding. Entropy represents the inevitable partial loss of an engine's ability to convert heat energy into work. From this experiment, the total entropy generated can be obtained by summing up the entropy change of water and metals. If total entropy generated for metal is greater than 0, it shows that the process is irreversible. If the value for total entropy generated was equal to 0, the process is reversible and the process is said to be impossible if negative value is obtained. So now I will pass my presentation to my next group member.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Abdurrahman Mizalani. So I will continue to the next topic, which is the theory for the experiment 7. So the heat capacity of a body is the amount of heat needed to increase the body's temperature by 1 degree Celsius. So the amount of heat lost by the warmer body equals to the amount of heat retained by the cooler body when two bodies with opposite temperatures exchange heat and an intermediate equilibrium temperature is finally reached. So heat loss, so here are the equation that we use. So heat lost by the solid, heat gained by the water, Cp water, and at equilibrium T to solid is equal to T to water. So while a system entropy change may be negative, so overall entropy generation is positive. So a mechanism must continue in a direction that is consistent with the concept of increasing entropy, which is more than 0. So the entropy generation measures the magnitude of the irreversibilities present during the process. Following the equation, so delta S equal to mCp ln T2 over T1, and the change of S total equal to change of S metal and change of S water. So I will pass to the next person.
Assalamualaikum. My name is Amran, and now I'll be explaining my part starting from apparatus up until methodology. Okay, to start off, first we have 10 materials that are going to be used in this experiment. Firstly is this metal string, then we have thermometer, aluminium coil, aluminium, iron and copper metal, two beakers, and a water. Then we also have a hot plate and a weighing scale. Okay, moving on into the methodology. So the first step is the copper metal was weighed by using a weighing scale. Then the value was recorded in table 1. After that, 100 milliliter of water was filled into the first beaker. After the beaker was filled, we then heat heated the water in the beaker using the hot plate here. Okay, the next step is, after that, the copper metal was attached with a metal string in order to carry it. Next, step 5 is that the copper block was lowered inside the heated water until it fully submerged. The copper was then allowed inside the water until the temperature reaches 80 degrees Celsius, which we assume that the temperature of metal and water were equal. The sixth step is that the second beaker was filled with 100 milliliter of water, and the initial temperature of water was measured by using the thermometer. The seventh step is that the temperature of water inside the first beaker was measured to ensure it reaches 80 degrees Celsius. After that, the copper metal was taken out from the first beaker using a metal string, and it was immediately transferred into the second beaker, which contains 100 milliliter of water. Next, the beaker was then covered by using aluminium foil in order to minimize the heat losses to the surrounding. Then, the temperature of the water was recorded for every time interval until it reached the constant temperature. The water was stirred throughout the process to ensure even heat distribution. And lastly, the experiment was repeated from step 1 until step 10 by using the aluminium metal and iron metal. So that's all from me. I'll pass to Fiona. Thank you.
Okay, for this experiment, I will explain about the result. So before we look at the table 1, the mass of the water is equals to 100 grams. So according to the methodology for this experiment, we should weigh each and every metal by using electronic balance, okay, in which copper is equals to 0.1153 kilograms, aluminium is equals to 0.0378 kilograms, and iron is equals to 0.1105. So according to the methodology also, uh, the each and every metal is heated until 80 degrees Celsius and is quickly transferred to the container filled with water. So the temperature of water at every 10-second interval is recorded in this table 1. So as we look in copper, the initial temperature was 29 degrees Celsius, and then the temperature increases at every 10 seconds and until it reaches 37 degrees Celsius. So the recording is stopped until it reaches an unchanged temperature. So for this copper, the unchanged is it is increased until 37 degrees Celsius. So the equilibrium temperature is 37 degrees Celsius. So, and for aluminium, the initial was 29 degrees Celsius, and then the temperature of water was increased until 36 degrees Celsius. So that is the equilibrium temperature for aluminium. And then for iron, the initial was 29 degrees Celsius, and then it was increased to 38 degrees Celsius as the equilibrium temperature for iron. So besides then recording temperature, we should also calculate the specific heat capacity, entropy change of metal, entropy change of water, and also the total entropy generated. So as we look into the calculation for, let's say we look at copper first. So firstly is the specific heat capacity, in which specific heat capacity can be calculated by equating two equation, which is heat loss by the metal is equals to the heat gain by the water. So after equating these both equation, we can obtain the value of specific heat capacity of copper, which is equals to 0.6756 kilojoule per kilogram Kelvin. After specific heat capacity is obtained, we can calculate the entropy change of metal. So the formula is given by the mass of metal times by the specific heat capacity of the metal, and then times by the ln of the final temperature, or T2, divided by the initial temperature, or T1. So in this case, the final temperature, which is T2 metal, is equals to 37 degrees Celsius, and then the initial temperature of the metal or copper is equals to 80 degrees Celsius. And then the entropy change of copper is equals to negative 0.0101 kilojoule per Kelvin. And then after calculating entropy change of metal, we should also calculate the entropy change of water. So the entropy change of water is equals to the mass of water times by the specific heat capacity of water, and times by ln of the final temperature of water divided by the initial temperature of water. So in this case, final temperature of water is 37 degrees Celsius, which is the equilibrium temperature, and then the initial temperature of water is 29 degrees Celsius. And then after that, we should also calculate the total entropy generated, which is equals to uh, the sum of entropy change of water and the entropy change of metal. So for copper, the total entropy generated is equals to 0.0008 kilojoule per Kelvin. And then the same calculation steps are repeated for aluminium and iron and should be recorded in table 1. So now I will discuss about the discussion part. And then according to the table that's given on the slide, this table explains that the comparison between the theoretical value and the experimental value of specific heat capacity for each and every methods that we use in this experiment. So for the experimental value is the value that we calculated from the and stated in table 1. And then for the theoretical value, we used some internet sources and reference books to find the value of the specific heat capacity for copper, aluminium and iron. So after that, we also calculate the percentage error between the theoretical value and experimental value. And then below that, there's a bar chart graph is given, which explains the specific heat capacity for each and every metals, which is compared with theoretical value and experimental value. And then from the table, it shows that the percentage error of specific heat capacity for copper is 75.03%, and for aluminium is 95.8%, and for iron is 80.44%. So we can say that each and every metal has a high difference between the theoretical and the experimental values of specific heat capacity. So since entropy generation is an irreversible process, the entropy change of a system or its surroundings can be a negative value. So it can also indicate the loss of energy due to work done. From the results of the experiment, for all entropy change of metals is obtained in negative values due to the heat loss and the temperature decrease. So while for entropy change of water is obtained in positive values for all metals tested. So in this, this is due to heat transfer into the water. Heat transfer into the water in which the temperature is increased. So the total entropy generated can be obtained by summing up the entropy change of water and metals. So we can observe that the value of total entropy generated for all metals are greater than 0, which proves that the process is irreversible. So if the value for total entropy generated was equals to 0, it shows that the process is reversible. And if the negative value is obtained for the entropy generated, then the process is said to be impossible. And next, I will discuss about the sources of error and method to minimize the error. So based on the difference and the result of the experiment, there might be few errors occurred in this experiment, especially parallax error, where the position of the eye is not perpendicular to the scale reading. So other than that, environmental error also may occur when the temperature of the lab is not specified and can also affect the temperature of water due to the presence of humidity or wind in the lab. So hence, instrumental error could be also considered, as the beaker used might not be fully insulated, uh, which also affects the temperature change. So the thermometer might touch the base of the beaker, and it also causes the temperature to vary and doesn't give an exact value of the temperature reading. So according to these errors, to minimize the errors occurred, we can also take some precautionary steps, which are make sure the observer's eye perpendicular to the measurement scale of the thermometer to avoid this error, which is parallax error. So the experiment should be handled in a closed environment space and make sure that all the fans are switched off. So to decrease the volume of air. So while holding the thermometer, make sure it does not touch the bottom of the beaker, so that we can get an accurate value of temperature and it doesn't affect the reading of temperature. So after that, we can also use the distilled water, which contains less presence of impurities compared to a normal pipe water. So make sure the beaker is insulated perfectly by closing the lid with the rubber band as tight as possible to avoid any heat loss to the surroundings. And then for the last part, which is the justification on the importance of stirring the water in the container, and also the importance of transfer of hot metal quickly into the water. So during the experiment, it is very important to stir the water using glass rod to make sure most of the heat is distributed throughout the water uniformly. So in this case, the heat transfer rate will increase and we will obtain a more accurate reading for the temperature. So hence, for the important transfer of the hot metal quickly into the water, if the metals are exposed to the surroundings for a long period of time, the convection process might occur between the surrounding of hot metals, not on the medium. So in order to avoid it, the hot metal needs to be quickly transferred into the water to ensure that there is no heat loss to the surroundings. So this also might gives an accurate temperature reading, as there will be less percentage error for the heat capacity.
Now we have come to the last part of this experiment, which is the conclusion. This experiment is considered success as the objective of this experiment are achieved. From the experiment, heat capacity obtained through this method is equal to 0.8120 kJ per kg.K for iron, 1.7622 kJ per kg.K for aluminium, and 0.6756 kJ per kg.K for copper. We can see that the heat capacity of aluminum obtained from this experiment is higher compared to copper and iron. After calculating the percentage error of these three metals, it shows that the percentage error of specific heat capacity for copper, aluminum, and iron are 75.03%, 95.8%, and 80.44% respectively. We can say that each metal has a height difference between theoretical and experimental value of heat capacity due to some errors. As for the entropy, the value of total entropy generated is equal to 0.0009 kJ per K for iron, 0.0007 kJ per K for aluminium, and 0.0008 kJ per K for copper. We can observe that the value for total entropy generated for each metal are greater than 0, which proves that the process is irreversible. So that's all from us. Thank you.